For over 4.5 billion years, the Earth has been blasted, burned, ripped and scoured. These phenomenal events have sculpted our planet through a series of devastating cataclysms. Our ancestors thought volcanoes were the doorways to hell. We think we know better, but we still live in a world driven by natural forces which we cannot control and which are indifferent to our needs. We live on a restless planet. We're only just beginning to understand the awesome power that can raise mountains, form the continents, open and close the seas. The fragile truce between man and the Earth is being broken all the time. We are learning more about the forces that drive our Earth and how to live with them, but it may be too late. '79 AD, Pompeii, Italy. A peaceful Roman city was overwhelmed by pyroclastic fires from Mount Vesuvius, a volcano that had slept through recorded history until it suddenly exploded. 20,000 people lived in Pompeii. Very few escaped the volcanic shroud. "2,000 years later, the people of Montserrat, a small Caribbean island, faced the same threat. In June 1995, the volcano of Soufriere burst into malignant life. It had been dormant for 400 years. "19 people have died, and half the island is uninhabitable. Where once there was a green forest is total devastation, an ash desert." Scientists from all over the world are trying to forestall an even greater disaster.
What we're looking at here is the Soufriere Hills volcano. And basically what it is this big scooped valley. And part of this valley is what we call English's Crater. And that's that big amphitheatre. Sitting within the amphitheatre is the present active dome. The magma is pushed up from below, and it comes out, it's exceptionally viscous, and it just fills up and up and up, forming this big dome structure. It's exceptionally hot, very unstable, and these blocks that are overhanging is what usually falls off, generates the rock avalanches, and then the pyroclastic flows.
Mark Davies can't just watch from the safety of the helicopter. He must get as close as he can to the flow. It's incredibly dangerous. At any moment, and without warning, the volcano might erupt again, and he'd have no chance of escaping.
We're quite close to the dome here. You can feel the heat coming off it. So it's not really a place we want to hang around. The cracks have opened up 6 centimeters in 3 days. So we'll have to keep an eye on them.
Pyroclastic flow is essentially like a snow avalanche. The only difference being that it's around about 800 degrees C. It contains big, huge blocks within it, sometimes the size of houses. It contains lots of poisonous gases, and all of that will travel at around about a speed of 80 meters per second in some cases, sometimes a heck of a lot faster. So you can't outrun it, you can't outdrive it, and in some cases the only thing that can get you out fast enough is a helicopter. Essentially, if you get caught in a pyroclastic flow, you really don't know whether you get crushed, whether you suffocate, whether you burn to death first, and frankly, I wouldn't want to know myself.
This is how Montserrat used to be before the catastrophe. An 8-mile paradise with green hills and tiny farms that had crept close to the mountain. The towns were full of memories of the colonial past. Now all that has gone. Sometimes ash falls like hail for a day at a time. The heat can be felt a mile away. The smell of burning sulfur fills the air. The sun is obliterated, and the midday sky becomes as dark as night. There is nothing to be done but take cover. Plymouth, the capital, was like Pompeii, a thriving port center of island life. It too lay in the path of the pyroclastic flow. Because they had warning, the people were able to escape, but slowly their town is disappearing under the pitiless flows and remorseless ash. A volcano can sit quietly for centuries until the pressure from below becomes too great and it explodes. What everyone on Montserrat wants to know is, will it explode again, and will it ever stop? The scientists' best hope is to monitor the earthquakes they know will shake the mountain before an eruption. 24 hours a day, they listen and watch.
This is the operations centre for the Volcano Observatory. It's monitoring the whole of the volcano. It's an early warning system, if you like. We have points all around the volcano, and so if the ground's moving, then the information that those machines gather out on the volcano is sent back here, and it's recorded on these pens, so it's a visual way of determining how much motion is occurring.
When the drum and the needle on the drum and the pen is going back and forth, the bigger the earthquake, the more violent that pen will move.
And the greater the chance of a violent eruption. But the technique is only a best guess. It's not foolproof. Distrusting science to save them from the force of nature, the population dwindles daily as more and more people escape to the safety of neighboring islands. Those who can't leave eke out a precarious existence in makeshift camps. Families are split. The young see no futures. The old can only remember the past. One in 10 of us live near an active volcano. Many choose to because volcanic soil is so fertile and productive. But will the people of Montserrat ever be able to return to their fields and old ways of life? Or has that gone, as lost as Pompeii? People and politicians would like clear-cut answers, but scientists know that's impossible.
If the eruption stops tomorrow, the dome is still up on top of the volcano. It's still unstable, and it'll still retain its heat, and it might stay like that for 5 years after the eruption finishes. Or it might cool down exceptionally quickly, and within 1 year, people could move back. We don't really know.
Montserrat's disaster is caused by something that happened over 4 billion years ago, when the Earth's crust broke into gigantic sections, forming the tectonic plates. Understanding Earth's tumultuous history is like reading an intricate detective story, for the Earth is unlike any other planet. Its restless surface is changing constantly, destroying the evidence of the past. But if you know where to look for them, the clues are still there. About 18,000 meteorites hit the Earth every year, hurtling down at 70,000 miles an hour. Most are small and do little damage, but each brings clues to the catastrophic formation of our planet. Geologist Roger Buick is working in northwestern Australia.
Even though it's just arrived, this is the oldest thing on Earth. It's a chondrite, a type of stony meteorite, and it's been wandering around the solar system for about 4,500 million years. And it's stuff like this that the Earth is made of. Space junk, glued together.
4.6 billion years ago, the molten Earth grew as a continual rain of mega meteorites pummeled it on its orbit around the Sun. Each strike brought with it raw rock, the material from which Earth could grow. It also brought explosive energy, raising the surface temperature of the primitive planet to over 1,800 degrees. A vast ocean of molten rock, 100 miles deep, covered the globe. Internal radioactivity raised the temperature even further. Earth became a melting pot. The meteoric iron began to sink to the center, dragged by the relentless tug of gravity. A kilometer sphere of molten iron would make the journey from the surface to the center of the Earth in less than 1 million years, a blink of geological time. The constituents of the Earth were forming. It had an iron core surrounded by molten rock. On the surface, a thin crust was developing. It behaved like these lava ponds, and the turbulent forces beneath began to fracture the crust. These are the tectonic plates, vast sheets of the Earth's crust, tearing and crashing over the planet's surface. They drift endlessly around the globe like giant bumper cars, joining and separating, carrying with them all the continents and oceans. There are 9 huge ones, many thousands of miles wide, and it's at their boundaries that catastrophes occur. When they clash, new landscapes are created, oceans shift, and mountains soar into the sky. Montserrat sits on the boundary of the Caribbean and North American plates, where volcanoes erupt and earthquakes shudder. The actual fabric of the land itself is made here, where the tectonic plates that form the ocean floor are torn apart, new lava continually emerges, and new volcanoes are born. In 1963, this act of creation could be seen by all. Some 10 billion square feet of lava erupted off the coast of Iceland to form the new island of Surtsey. It emerged in a matter of days, just like volcanic islands on the primitive Earth. All over the planet, these islands appeared, and in time, they were to form the first continents. Clues as to how this happened are found in the Canadian Rocky Mountains. The outer shell of Earth, the lithosphere, carries the continents. It's made up of great stratas of different rocks extending 60 miles down into the Earth. Most of its structure is unknown. The deepest man has ever drilled is 9 miles. Exploring deeper needs a different approach. To discover just how their land was formed, a team of 700 scientists, the modern equivalents of early map makers, are charting this invisible territory. They use shock-wave detectors, geophones, which the teams are placing all over the landscape. This is the world's biggest subsurface exploration experiment, the lithoprobe. In the Yukon province, the chief scientist is Charlie Roots.
Geologists who work in sedimentary rocks are used to continuity, both in oldest rocks to youngest rocks, as well as being able to take the same rock formation for a long distance. You can't do it in these mountains. The rocks on the surface indicate a large platform of limestone, and the surrounding areas are rocks that have no relation to that. They are bits that are not part of the continent that appear to have come from somewhere else. These canyons show the folds and the twists that the rocks have undergone as they've been pushed up against the ancient continent. The problem is that we only get to see the rocks that are at the surface, and in an area where rocks are steeply dipping, there is far more of the story buried beneath our feet.
To send shock waves deep into the crust, 200 pounds of explosive are buried in the ground.
We're digging 3 holes for the geophones that we're going to be putting in here so that we can have a 3-component orientation system to measure the seismic wave that comes in. We have a vertical geophone, which will measure the vertical component of the arriving wave. There is a north-south geophone that will measure the north-south component of the incoming wave. And we have an east-west geophone to measure the east-west component of the incoming seismic wave.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
As the shock wave races down through the ground, they hit something hard, much harder than the surrounding rock. The shock waves are reflected and speed back to the surface, taking their precious information to the geophones. Analysis of the results shows that under the Rockies are the buried remains of ancient volcanic islands. Over the last 200 million years, hundreds of these islands were grafted onto the North American continent. They form much of the land west of the Rockies, stretching from Mexico to Alaska. This is a clue as to how the first land masses were created. But until very recently, science was at a loss to say just when it happened. Then one day, prospecting for minerals in northwestern Australia, Roger Buick made a startling discovery. This rock is part of the oldest land surface on Earth. It has miraculously survived the never-ending cycle of formation and destruction of the crust. The vertical stripes have endured for over 3.6 billion years. At the same time, the Earth began to cool. There was moisture in the atmosphere, condensing in pockets, but not enough to create oceans or rivers. There was no oxygen in the air. It was inhospitable with no trace of life. A new theory suggests that in time, water, maybe enough to fill the world's oceans, arrived from deep space, brought on ice comets. Cosmic rain continues today, with small 20 to 40 ton ice comets striking the Earth's atmosphere once every 3 seconds. They add 1 inch of water over the entire surface of the globe every 20,000 years. When the atmosphere was saturated, the rain began. An endless ocean grew, and when the skies finally cleared, the Earth had been transformed into a watery globe. This is the time when life is thought to have begun. Echoes of those beginnings can still be heard today. Our most ancient ancestors, the most resilient creatures ever evolved, have survived unchanged for billions of years, living in solid rock. Drilling to great depths into the rocks at Idaho Falls, Princeton microbiologist Tallis Onstott is hoping to take a closer look at their descendants.
What I find truly remarkable is that within this core barrel is a massive piece of rock from 200 feet below the surface, and yet it contains as many bacteria in it as there are people on this planet. Now, these are living bacteria, and they live at temperatures approaching the boiling point of water. They live at pressures that are 100 times the atmosphere. They live in a salty, briny solution that's alkaline and contains gases that are toxic to us, and yet they still manage to survive.
They're known as extremophiles because of their extreme living conditions. To get a closer look, the scientists first extract them from their rocky home.
The really exciting thing about heat-loving bacteria is that they're the most primitive organisms on the Earth. And the fossil evidence in the most ancient rocks on Earth indicate that these types of organisms must have existed 3.7 billion years ago.
With skill and care, the team work inside glove boxes. Here they can manipulate the sample under sterile conditions. They go to great lengths to ensure that the only bacteria inside the tent are those that have made the journey up from the Earth.
We need to pare away the outside of the core so that we can remove any contamination that may have occurred during the process of coring.
The core is then placed in a press and crushed to a fine powder. Then a sample is taken from the powder and a culture developed of the bacteria. These are the earliest common ancestors of all life, a colony of extremophiles. Observing how microbes survive thousands of feet below the surface, some scientists have speculated about life elsewhere. Could there be tiny extraterrestrials buried in the same way on other planets that appear outwardly sterile? In the sedimentary rocks of Australia's Karenjini are all the clues that solve another chapter of Earth's history. This was the first place where life and the land began to interact, and the traces are clear to this day.
The impressive thing about the place is how red it is. In fact, red rocks stretch for hundreds of miles in every direction. The reason they're red is because of this red mineral, hematite, iron oxide, or rust. And the way they formed was when dissolved iron in the ocean combined with oxygen and precipitated out as iron oxide, settled down to the sea floor and accumulated on the bottom of the sea. Initially, the atmosphere of the Earth had no oxygen. The same applied to the oceans. These rocks record an intermediate period when there was still no oxygen in the atmosphere, but the upper layers of the ocean contained oxygen. There's a huge amount of iron oxide here. The sheer volume suggests that the oxygen could only have had one plausible source: biology, living organisms excreting oxygen as a byproduct of photosynthesis.
After 2 billion years, the oxygen had finally combined with all the iron. For the first time, free oxygen was able to escape into the atmosphere, and the air became breathable. Deep into the Australian outback is more evidence of primitive oxygen-producing organisms. In a secret location Buick discovered are some of the world's oldest and rarest fossils.
What I've done is step back more than 3/4 of the way back to the beginning of Earth history. And here are wrinkly layered sediments that occasionally dome upwards. These are stromatolites, sedimentary structures created by filamentous microorganisms trapping sand and mud between their little filaments. Those microorganisms were probably photosynthetic. The layers thicken over the tops of these domes, competing with each other to get nearer the sunlight. Now, these stromatolites are remarkable for their great age, 3,450 million years old. Not only are they remarkable for that, but we can also infer something about the environment in which they lived. Just back here are gypsum daisies, little star-shaped clusters of gypsum crystals, calcium sulfate. These form when seawater evaporates in a shallow pond near the edge of the sea. Living stromatolites only grow when they're almost permanently submerged in water, so you only see them exposed at very low tide. These grew here about 5,000 years ago, when the sea level was about 1 metre or so higher. The living carpet of bacteria that formed them died off as the sea level gradually dropped, and the sediment that the bacteria trapped was turned into limestone.
These tiny bacteria were the first organisms to live together in colonies. By producing oxygen, stromatolites changed the planet forever. life flourished and became a force to shape the world. But geological upheavals can spell disaster. 200 million years ago, the supercontinent Pangaea, which stretched unbroken from pole to pole, began to split in two. It took 65 million years. Two continents we know today were shaped by another upheaval that hit the remains of the supercontinent in the south. In the jungles of South America are found one of the most remarkable features on the face of the planet. This whole landscape owes its existence to this violent chapter of Earth's history.
Iguazu Falls, Argentina. For me, the most spectacular waterfalls in the world. Not only because of the spectacular scenery here, 250-foot-high waterfall, a mile wide, but because of the spectacular geology. What's more, the rocks of the falls contain evidence pertaining to a geological event that took place here 135 million years ago. The geological evidence is here in these rocks. This is basalt, a hard volcanic rock, stained red by iron oxide, oxidation of the iron within the rock. In fact, we're standing here at the base of a basaltic lava flow more than 100 feet thick. Just one of many lava flows in this area, which form a pile of lava more than a mile thick. In fact, in the waterfalls, one can see steps of the waterfalls, which shows the individual lava flows in this pile. Imagine volcanic eruptions so enormous as to produce lava flows erupting from giant cracks and fissures in the Earth's crust, flowing out over an area twice the size of the state of Texas, more than 250,000 square miles. An enormous volcanic event. Massive amounts of sulfur-rich gases spewing into the atmosphere, droplets of sulfuric acid forming a veil that cuts out the sunlight and cools the climate, sulfuric acid rain killing the vegetation, the makings of an environmental disaster of enormous proportions. This is 135 million years ago, at the end of the Jurassic period of geological time, a time when there were mass extinctions of many forms of life. There's evidence here in these rocks for an even more dramatic event in the history of the Earth. And here's just the piece of evidence that I need.
On the other side of the world, across the Atlantic Ocean, is the world's most ancient desert. It dominates most of the southern African country of Namibia.
I've traveled more than 4,000 miles, and the rocks are exactly the same. They're basalts, and the age is 135 million years. Clearly, when these rocks were erupted, as floods of lava traveling hundreds of miles, South America and Africa were together as one supercontinent.
The Atlantic Ocean, which now divides Africa and South America, owes its very existence to this geological cataclysm that tore Pangaea apart.
The supercontinent looked like this, made up of the present-day continents of Africa, South America, India, Antarctica, and Australia. The cracking started here and split the continent into the present-day continents of South America and Africa.
In geological terms, it happened incredibly fast. The crack opened northwards at a speed of 2 inches per year, the split unzipping the land as it went along. Fountains of volcanic fire leapt through the crack. The entire process took only 5 million years to complete. Evidence of the unzipping is clear. The shorelines of South America and Africa match perfectly, and under the ocean, the mid-Atlantic ridge divides the two continents almost exactly down the middle, where it still pushes them apart. Until recently, scientists had never visited the place where this spreading occurred, but now even the depths are giving up their secrets. Alvin, The world's first deep-sea submersible led the way to this unexplored terrain.
Land is valving. The valve is open, the light is on, the hatch is shut, oxygen's on, and the scrubber's scrubbing.
One of the first regions visited was the East Pacific Rise, part of the spreading area called the Mid-Ocean Ridge. They expected to find evidence of the Earth at work. What they actually discovered lay beyond imagination. From this pioneering work, scientists worldwide are able to study the extraordinary geological systems 4 miles beneath our feet. Lindsay Parson heads a team at the Southampton Oceanographic Centre.
These are really some of the most amazing images that I think we have of the ocean floor. They're taken from about 3,000 meters down. They're in the deepest, some of the deepest parts of the ocean floor. And we're here looking at hydrothermal systems where bottom water of the sea is being sucked into the ocean floor, is being heated from the heat engine inside the Earth, and is being delivered out into the ocean floor again once it's dissolved and leached out minerals and chemical compounds from the rock itself, which is why the smokers, as we call them, are black and densely coloured here.
The pressure is an immense 2 tons per square inch. Water is superheated to over 700 degrees. It's highly acidic, full of hydrogen sulfide and heavy metals. The equivalent volume of the world's oceans is siphoned through the vent systems every 30 million years. Samples prove that the sea floor along the ridges is the youngest on Earth, endlessly reborn. But an even greater surprise lay in store. Even in this harshest of terrain, life takes hold. The black smokers are warm water oases around which familiar species, shrimps, foot-long clams, and mussels thrive alongside more bizarre forms, 6-foot-long tube worms and strange fish.
The majority of the life forms here depend not on light to maintain their existence. They absorb and fix chemicals from the hydrothermal vents to keep them alive. They are chemosynthetic communities rather than photosynthetic communities.
Far from the sun and the air, these creatures have evolved in a self-contained environment separated from the rest of the biosphere. They have managed to survive the endless geological upheavals that rack the world above them. Maybe one day, long after we are gone, they will inherit the Earth. Here, scientists can also watch the extraordinary process of the seabed actually creating itself.
The hydrothermal systems lie along the mid-ocean ridge. The mid-ocean ridge is the line along which the tectonic plates move apart from one another, allowing hot molten rock from the interior of the Earth to well up and to form new ocean floor, the youngest part of the world as we know it.
The mid-ocean ridge is the Earth's crust factory. New molten magma endlessly emerges to force the cold, older lava away from the ridges. Enough lava is created each year to bury New York 100 feet deep. And this unrelenting pressure is like a wedge between the plate boundaries, driving them and their continents on their unstoppable journey. Accurate mapping of the seafloor is now possible and crucial to understanding the system on a grand scale. By careful monitoring, scientists can calculate just how fast the seafloor is spreading and the plates moving. A sonar sledge is towed across the ocean bed. Individual snapshots are processed by computer and a photomontage created. That information is turned into 3-dimensional maps. What emerges is that the sea floor is full of great valleys and deep trenches, and that here is the largest and tallest range of volcanic mountains on Earth, 40,000 miles long, sometimes 5 miles high, stretching around the globe like a seam on a baseball. Oceanographic research is difficult, but there is a country that might have been designed as a geological laboratory. The one place where the mid-Atlantic ridge becomes exposed on land. Iceland. The land here is being torn apart. The rift shows exactly where the plates carrying America and Europe are being forced away from each other at about an inch per year. And Iceland is in the middle. The land is continually reshaped through eruption and rifting. The lava from the flows forms vertical dikes and horizontal beds, just as it does on the ocean floor. Geysers and mud pools are evidence of the heat and pressure just beneath the surface, continually seeking a way to escape. Ice and fire is a deadly mixture. In 1996, part of the mid-ocean ridge erupted under the ice cap. It rapidly melted its way through 300 feet of ice, forming a deep gorge. The meltwater raced away to fill a subglacial lake until it could no longer be contained. In the catastrophic flood that followed, 10 square miles of land drowned. This time, the damage was only to roads and bridges, but in Iceland, the earth is always menacing. In 1975, the Krofla volcanic eruptions began, lasting 9 years. 14 square miles of basalt spewed out, in some places widening the land itself by 28 feet. In 1973, the town of Jaime was almost overwhelmed when the nearby volcano woke from a 5,000-year sleep. Five months later, the lava and ash had destroyed 300 houses, reshaped the harbor, and added nearly a square mile of new land. Living in a laboratory can be hard. But if new land is continually being made at the crust factory along the ridges, why isn't the world itself constantly expanding? The reason is subduction, the giant recycling process that has been going on since the world began and which causes most volcanoes and earthquakes. Subduction zones are the graveyards of the old, dense oceanic floor. Where it collides with the lighter continental crust, it's forced down. Pulls the rest of the plate with it to be melted in the ferocious furnace of the inner earth. The plates don't die peacefully. They go with a bang. The old ocean floor carries water into the mantle, which mixes with the magma. When the pressure can no longer be contained, it explodes. In that most awesome of natural events, a volcanic eruption. Most of the world's volcanoes are in subduction zones, but there are exceptions. Kilauea is on the big island of Hawaii, part of a chain of islands in the middle of the Pacific Ocean, thousands of miles away from any subduction zone. But the whole chain is formed entirely from volcanoes, whose rivers of fire heave and bubble at temperatures of 2,000 degrees. What provides the furnace for all this outpouring if it's not the crashing of the tectonic plates? The volcanologists have an explanation.
The lava that's flowing and spattering behind me is the surface manifestation of a thermal anomaly, or a hot spot that's deep within the earth beneath my feet. Where we are now on Kilauea volcano on the big island of Hawaii is at the southeast end of a 6,000 kilometer long chain of seamounts and volcanic islands that have formed as the Pacific plate has moved north and westward over the last 80 billion years or so at a rate of around 9 or 10 centimeters per year. So as the plate moves over this hot spot, you burn through the lithosphere, forming a volcanic island, and then the plate moves on, and a new island forms further to the southeast.
The hotspot has made Kilauea the tallest mountain in the world, 30,000 feet from its base on the seafloor, taller even than Everest. It's also one of the most studied. But scientists can't always wait for the lava to come to them. They must catch it as it bursts through the crust. Carl Thornburg often goes fishing with a cable in a red-hot pond. And sometimes he has to get even closer. It's extremely dangerous. At any moment, the lava may spurt out unexpectedly, leaving Thornburg with nowhere to run.
Behind me is a perched lava pond that's being fed from a vent off to my left. You can see that there's lava spattering and overflowing on its edges. I'm going to attempt to scoop a sample of molten lava, hopefully with a hammer, so I won't have to use a long cable to throw it in. And it'll be extremely hot. We have to worry about gases, and we have to worry about breakouts near the edge of the pond. So we'll see how it goes.
Thornburg is risking his life. But unless scientists can learn how to forecast eruptions, volcanoes will continue to be an uncontrollable threat.
Okay, we'll take this sample back to the USGS Observatory and we'll prepare it for chemical analysis. The chemistry of Hawaiian basalt is unique compared to volcanic deposits near subduction zones or near mid-ocean ridges, and that will be reflected in the chemistry that we see. More importantly, we're looking at very subtle variations in chemistry that can be correlated with the eruptive history of this volcano, so it will allow us to predict what may happen next.
High on Maui, the next island in the chain, NASA scientists at the Satellite Laser Ranging Station are preparing for a long night's work. They're setting up to fire a laser beam at a satellite target orbiting the Earth. The information they gain will tell them to the inch how fast the island and the Pacific plate on which it rests are moving across the ocean. They have to time the firing exactly to be sure that no planes are passing. The laser beam would blind any pilot who might look at it directly.
Okay, we're at 227 azimuth, 18 degrees L. This is starlit. Culmination's at 74 degrees. We're rotating clockwise.
Okay, you'll be clear to fire.
We're at 21 going down.
The laser beam flashes out and bounces back, pinpointing their location. 22 years of calculations confirm that Maui and the Pacific plate are moving northwest at the rate of 2.5 inches a year, amazingly fast. This is the absolute proof that the surface of our planet is in constant motion. Tectonic theory says that the volcanoes of the Hawaiian chain should get progressively older and become more eroded the further they travel from the hotspot, and they do. One day, the raging fires of Kilauea will be as silent and cold as these dead cones. But the heir to them all is already emerging. As one island dies, a new one is formed.
The hotspot is currently moving or manifesting itself at Loihi, which is a submarine seamound to the south of the big island of Hawaii and still more than 3,000 feet beneath the surface of the ocean. Maybe another 100,000 years before we see Loihi surface.
At the same time, the hotspot is causing destruction elsewhere. The pressure of the continual input of magma from below is bulldozing open this great crack which stretches across the length of the island. It is more than 80 feet deep, and it's splitting away at 3 inches a year. Eventually, the whole side of the mountain will fail and collapse into the sea. It will send a giant wave racing away to the Pacific Rim to reach the west coast of the Americas in a few hours, causing massive destruction. We can't predict or prevent these catastrophes. The geological truce between ourselves and our restless planet may be coming to an end. Cataclysms may have caused extinctions and disasters, but they have also shaped the Earth and produced an environment in which human life could flourish. The air breathable, the seas are warm, climate mild, the ice rooted firmly at the poles. In fact, a geological truce. But that truce may be coming to an end. The forces that drive the Earth are impervious to our needs. With man so widely spread across the planet, cataclysms of nature will turn into human catastrophes. Every movement of the plates brings the danger of disaster nearer. "50 million years ago, the Asian and Indian plates were about to clash. Separated by a dying ocean, they collided with fantastic force. Neither would give way, and the land had only one way to go: up. This is the world's highest mountain range, the Himalayas. This entire area was uplifted from sea level to over 5 miles high in less than 30 million years. How do the scientists know? From the evidence of the rocks.
There's dramatic evidence for this uplift right in the face of Everest and Lhotse. The famous yellow band that you can see cutting across is actually a marine limestone. It was formed in the bottom of the ocean.
So 50 million years ago, the tops of these mountains were at the bottom of the sea. It's hard to believe.
We have similar evidence from Tibet, where we find things like this, ammonite fossils of marine creatures at now more than 4,000 meters above sea level. Certainly these tell us that plate tectonics supplies enough force to lift things from the bottom of the ocean all the way to here, the top of the world.
This is the only place where 2 continental plates are colliding on such a scale, and the mountains are still growing as a result of the tectonic squeeze. Even Everest is still stretching skywards.
I can't quite feel it, just standing here on a piece of Himalayan rock. The Earth that I'm standing on is actually moving up at about 10 millimeters a year, and is moving to the north at an even faster rate than that, maybe 15 millimeters a year. The reason why we can measure this is because of these fantastic receivers. They use 4 satellites up in the sky above me to solve a simple triangulation problem, but they're so accurate that they can give me something like 1 millimeter of accuracy in the horizontal and more like 5 millimeters in the vertical. That way I can come back year after year. We can see that this point drilled into this rock that's attached somehow to the root of these mountains and the continental plate that they're stuck to is moving.
There is another way that Rebecca Bendick and her colleagues can discover exactly how the Himalayas are growing. They have found an area in the foothills, 10 miles south of the highest peaks, that is rising even faster than the mountains. The clues to the uplift are found in the fast-flowing rivers that tumble through these valleys.
You can think of this river in 2 different ways. One is that this land is still and the river's cutting down. The other way, and I think a better way to think about it, is that the river is staying at sort of a constant position with respect to the sea, way off in the Bay of Bengal, and the earth around it is rising up. So in order for the river to stay in one place, it needs to cut down like a knife through butter.
But in some places, the river cannot cut quickly enough to maintain its natural equilibrium. Here, the land rises faster than the river erodes it down, and a giant step is formed, creating white water and rapids.
We're looking for places where the river is a lot steeper than its average gradient anywhere along a stretch. Those steeper places are corresponding to places where the uplift is quick, so quick that the river can't keep up. This will give us clues about places to come back and do more intensive GPS research to try to pin down the uplift rate.
It seems this area is continuing to rise faster than the high peaks. One day, this riverbed will be taller than Everest.
Taking data in this way is dangerous, but with a little bit of care, it's definitely worth the good information that we get about the Earth.
That information is vital for the 100 million people living in the danger zone round the Himalayas. Earthquakes are common. 30,000 people have been killed in the last century alone. This area has been quiet for 700 years, and a major quake is long overdue. Rebecca Bendick's monitoring shows that the convergence of India and China at 2 inches a year is setting up immense stresses which must eventually be released. A solar-powered GPS station will send back information 24 hours a day, hopefully giving an early warning.
The crux of the matter is that we need to know how that total convergence is partitioned over the faults. If all 60 millimeters of convergence has to be accommodated in one place, on one fault, on this one narrow line, then the earthquakes we have there are going to be big and they're going to happen often. But if instead all of that strain is accommodated on several different faults, something like an accordion, then each fault can only be expected to fail less frequently and less violently.
Earthquakes are appallingly destructive to human life, but for scientists, they have their uses. The seismic waves are like sonar. By listening as they pass through the Earth, a picture can be built up of a place no one will ever see. First, the waves race through the crust, the skin on the planet's surface. In some places, only 4 miles separate us from the intolerable heat of the mantle and interior of the Earth. 3,000 miles down in the core itself, the temperature reaches an unimaginable 7,000 degrees. It is the ultimate nuclear reactor, the engine driving the planet. Cooling comes by gigantic convection currents in the mantle, and it's that heat rising with the hot magma that forces the tectonic plates to shift. Earthquakes are a ferocious manifestation of the power of the Earth's plates. More than 1.5 million people have been killed by them in this century alone. Most quakes occur along fault lines where the plates grind together. Scientists can't tell us when this terrifying destruction is likely to occur. They can only tell us why.
You can't have an earthquake without a fault. And I'm standing right now on what is perhaps the most famous fault in the world, the San Andreas Fault, that extends from Mexico down south, way up to Oregon in the north. This is one of the few places in the world where you can stand with one foot on one tectonic plate and one on another. In other words, this ground here is attached to New York and Iceland. The ground here is attached to Hawaii and Japan.
At this part of the fault, the plates are stuck. They should be moving at 2 inches a year. The last earthquake was 100 years ago, and the fault is storing up the unreleased energy. The longer the plates are stuck together, the larger the ensuing tremor will be. Further north, the plates are sliding smoothly past each other. The evidence is clear from the way this fence has buckled.
We're on the San Andreas Fault south of San Francisco, and this is an interesting part of the fault zone because the 1906 earthquake ruptured through this field here across the road and stopped about here. But this fence was built after the earthquake. In other words, the fault has been sliding ever since then. So what's going on here exactly? And you can see here there are cracks in the road. These have grown since I was last here, all over the road here. And I have a machine in the field and I am absolutely dying to see what it says. Let's go have a look. What we have in the field here is a creep meter. A creep meter measures creep on the fault, the creep that's caused the offset of this fence. It consists of a rod that is attached firmly to that side of the fault, passes through the fault into the box here. Inside the box is a computer that's been measuring things. Now, I have to be rather careful because sometimes there are snakes here. Oh, not this time. Good. What's left are black widows and ants. All right. So here is a computer that's been measuring for a year. It records the movement of the fault every minute to about 1/1000th of an inch. So let's download the data and have a look. There we are. Well, it looks as though we've had about 7 millimeters of creep, like this site usually has. But the interesting thing is it's all limited to a very short period of time. If you look here, you can see the fault has been locked for most of the year, but suddenly, in the middle of September, it takes off, and it slips about 5 millimeters in the space of a couple of hours, and it continues to slip in the next few days. In other words, a whole year's budget of slip occurs within the space of a few days. That might not seem much, 5 millimeters, but it's affecting a long section of the fault, maybe 5 miles long, involving millions of tons of rock. Now, it really doesn't matter here. This is a nice sort of field, there aren't any people, but further north, this creep process and the things that are happening beneath the earth are far more sinister.
San Francisco is home to 2.5 million people and lies right on the Hayward Fault. In its 200 years history, it's been hit by 3 killer quakes. Scientists know the slippage on the fault has begun to slow down, a warning sign. But when will it strike? In 1989, 67 people died in an earthquake at Loma Prieta, part of San Francisco. No one had foreseen it coming.
Everybody have a
Earthquakes are an inevitable consequence of the movement of plates. We cannot stop plate motions, and therefore we cannot stop earthquakes. But we can begin to live with them. And the first thing we must learn to do is to build our cities better.
As the world population grows, so does the danger. There are now more than 100 cities around the world with population of over 2 million, and more than half of those are on plate boundaries or places where earthquakes have already struck. Los Angeles is the most vulnerable of all the places on the West Coast fault line. This stretch of road shows why. Not only is it on the San Andreas, but here the fault is being forced round a bend. Where this happens, the rocks get compressed with enormous force. They cannot go sideways, so they go up. The movement curls the rocks, bends, folds, and crunches them, faulting and distorting the land. Many faults never surface, although scientists know they're there. Known as blind faults, they are probably the most dangerous of all.
You come down the hills here until you hit the plains, a flat area where 11 million people live, and across there, far behind the tall buildings of downtown LA, we think there's a fault right there, right underneath the center of LA.
At 4:24 in the morning on the 17th of January 1994, the suburb of Northridge was shaken to its foundations. A blind fault had fractured 11 miles down, causing some of the most intense ground shaking ever recorded. Ground acceleration exceeded gravity, throwing buildings, furniture, and people into the air. 61 died, 9,000 were injured. Buildings, roads, and bridges were destroyed. Damages ran to $20 billion, and the aftershocks went on for days.
When it goes, like Northridge did, seismic waves are spread all over the basin, big ripples shaking all the buildings. It's exaggerated where the sediments are concentrated in the basin here, because the basin's completely flat, and it's flat because it's washed in there from the mountains by water, so we have saturated sediments.
When the sand and water combination is shaken together, it turns liquid for 5 minutes after the shocks, causing tall buildings to destabilize and fall. It's called liquefaction and presents an enormous and unpredictable danger. And there is another geological trap waiting to spring. The San Gabriel Mountains stretch from the San Andreas Fault down to the Los Angeles Basin. As the earthquakes crack and shudder along the faults, they are being inched towards the city. Here the fault is pink and the mountains in yellow. This is how they have swung so far. In some distant geological future, they will cover the city completely. What does the geological future look like? What clues are hidden in the mountains, deserts, and seas? It's difficult to grasp that the march of the Earth is unstoppable.
We've been very lucky because modern society has actually developed at a time when very little has been happening geologically. So we've been in a period of geological quiescence. Now this isn't going to last. We know that there are going to be major global catastrophes occurring in the future, gigantic tsunami, big volcanic eruptions, more impact events. And on that basis, we know that we're all living on this planet simply by geological consent.
Ice is crucial in helping to keep the Earth's climate mild enough for life to survive. But worldwide, the temperature is rising, and the ice is melting. If this keeps happening, sea levels will rise. A rise of only 15 inches would spell catastrophe for low-lying countries and low-lying cities.
Major sea level rise in itself may be catastrophic for the planet, but actually there are unexpected effects as well, and that is that rising sea levels may trigger volcanic eruptions. We know this because we've been looking at the relationship between changing sea levels and volcanic eruptions in the Ice Age, when we had changes of 100 or 200 metres in sea level over a few tens of thousands of years.
Maguire's new work on Etna seems to show that the more rapidly sea level rises or falls, the more violently the volcano tends to explode.
When sea levels rise around coastal volcanoes such as Etna, they have a rather interesting effect. If you imagine the volcano sitting on a plate with Etna here, if you then load the other half of the plate by sea level change of 100 metres or so, it has the effect of bending it. And what that does is set up tensional stresses within the volcano, and any magma sitting there will burst its way out in the form of an explosive eruption.
In modern times, we haven't really experienced the full terror of a volcanic catastrophe. If Bill Maguire's theory is right, such an event could hurry in the new ice age, because nature can wield a two-edged sword. Rising sea levels could cause volcanoes to erupt, spewing debris and sulfur into the atmosphere. That will cut out the heat from the sun, so the Earth will cool. That will make the ice form again, freezing the oceans so sea levels drop once more. And that sudden fall may trigger more volcanic activity, pumping more material into the atmosphere, making the Earth even colder, ushering in the dark and the ice and the long winter. There is evidence for many ice ages during Earth's history, but the last full and most severe one began 45 million years ago, just as the Himalayas were being formed. One theory attributes the dramatic cooling to this tectonic turmoil. The mountains are littered with limestone rocks and rubble. This debris would combine with rain and carbon dioxide in the air in a chemical reaction which removed millions of tons of the gas from the atmosphere. With less greenhouse gas to keep it warm, the entire planet would cool, triggering the Ice Age. At the edge of the vast ice sheets, immense glaciers advanced relentlessly. Nothing could resist as they raced forward at speeds of up to 10 feet a day. The ice covered more land, so more of the sun's heat was reflected back into space, chilling the planet further. At its coldest, Earth was covered by 3 times the volume of ice on the planet today. This ice locked the water away, trapping it on the land. With less available water, the world's sea level dropped by 425 feet. Today, the Caribbean island of Grand Bahama holds the clearest clues to the dramatic change in past sea levels. Microbiologist Steffi Schwab has been piecing the story together. Hidden deep in a mosquito-ridden mangrove swamp is an unlikely entrance to a mysterious ancient world.
These caves have a story to tell concerning past sea level fluctuation and past interglacial and glacial periods. What makes these caves particularly exciting is that they are one of the last unexplored frontiers, and they turned out to be one of the world's largest and longest known cave systems. We move from the entrance into a very large cathedral room where we can see the ceiling comes up to what we commonly call these cave systems, which is a blue hole. you always find, when you go into these large cathedral rooms, a very large rock pile in the center. And usually the collapse happens when the water is no longer in the cave, supporting the ceiling. I'm now swimming through what is called a mixing zone, and this is where the fresh water mixes with the seawater and causes what we call a shimmer. This mixing zone is responsible for aggressively attacking the wall rock. It's like soft cheese. Normally, limestone could not be removed with your finger. You would need a rock hammer and a chisel. This is how we know that the caves have formed hundreds of thousands of years ago. But we also know by evidence that we have found that the caves have been dry in the past. 20 meters down further into the cave system are these bat droppings that have been fossilized. And we know the only way that this can happen is when the caves are dry, because bats do not swim. And when bats roost in the ceiling, the droppings collect on the rock and they become very hard. Deeper into the cave system, we find another bit of evidence, and that is this red Saharan dust, which gets blown into the stratosphere during frequent storms which occur in the Sahara Desert, and will actually find its way into these caves. Most likely it's happened during periods when the cave was dry. The final bit of evidence which supports the fact that the caves have been dry are these beautiful stalactite and stalagmite gardens that we find at 28 meters plus. Stalactites and stalagmites form during the ice ages and have formed over a period of hundreds and thousands of years. What happens is the water is frozen in the ice caps on the poles, sea level drops, and the caves become dry. And usually during ice ages, it rains a great deal more in the tropical regions of the world. This rainwater percolates through the bedrock or the ceiling rock and dissolves the rock that's there, and it comes out in the drip water and crystallizes, just like an icicle. And basically these are rock icicles.
The ice ages affected and shaped the landscapes, but sometimes the clues are so gigantic it's hard to recognize them. In Washington state, in the Grand Coulee Canyon, are the channeled scablands. For years, a succession of scientists tried to work out what could have caused erosion on this scale. USGS scientist Richard Waite is the latest investigator.
This rock, the size of a 3-story house, looks like it's part of the bedrock. Part of this basalt that forms this vast landscape. But the structure in the basalt is horizontal, as you can see, whereas the structure in this rock is vertical. In other words, this big rock has been moved. But the biggest clue in the landscape is the landscape itself. This gorge is carved in basalt, one of the hardest of rocks. It ends in a sheer cliff, 400 feet high, and it's in the shape of an enormous horseshoe. It's like the gorge below Niagara Falls. But this, Dry Falls, is fully 2 Niagaras high and 3 wide.
Waite is continuing the work begun by geologist J. Harlan Bretz in 1923. Bretz was the first to say that this entire landscape was a gigantic riverbed formed by 3,000 square miles of the Columbia Plateau being swept away. No one believed him because the scale was so huge, But he was certain that the only explanation for this scale of damage was an enormous flood. The whole area was obliterated and changed forever as the torrent flooded through. Even on the top of the cliffs, the water was over 100 feet deep. The basalt cliffs are amongst the hardest structures found in nature. Resistant to weathering and erosion, these walls could only have been cut by an enormous body of water. One by one, these columns of frozen lava were quarried from the rock face and carried away by the raging torrent, causing the wall to retreat and the cataract to widen. So it was accepted that this is how the channeled scablands were shaped. But an important part of the mystery remained. Just where could all that colossal, earth-shattering volume of water have come from?
100 miles to the east, geologist Joseph T. Pardee had described an enormous Ice Age lake, Glacial Lake Missoula. This lake held in some 600 cubic miles of water. 600 cubic miles is all of present-day Lake Erie, plus all Lake Ontario. The lake was held in by an ice dam that had crossed the Clark Fork River and dammed it. The lake rose 2,000 feet deep against the side of the ice dam, but there was no evidence to link the lake with the channel scabland. In 1939, Pardee discovered a series of giant ripples. These are like sand ripples on the beach, but they are of enormous size, hundreds of feet apart, 10 feet high and more, and they're composed of gravel. Such a feature could only indicate a swift outflow from Glacial Lake Missoula.
The gigantic ice dam held back the water until it reached a critical level. When it was 1,800 feet deep, the pressure of the water was so immense that it forced its way through the base of the ice dam. Having found a weakness, the icy waters raced on, widening the split and weakening the dam catastrophically. The waters of the entire lake were released in a devastating discharge.
This discharge was 10 times the flow of all the world's rivers. That's almost beyond belief.
In 1926, a freak flood created a 100-foot deep canyon, 200 miles away in the Walla Walla Valley. It revealed many layers of silt. Waite realized that this area must have been in the path of the great floodwaters that formed the channeled scablands.
This white layer here is an ash that we know is from Mount St. Helens. We've analyzed it chemically, mineralogically, and it clearly came from Mount St. Helens. And we know its date. By radiocarbon dating, we know that this is 15,000 years old, approximately. Therefore, we have a beautiful timeline running through this section of 15,000 years.
The ash could only have fallen after the flood had passed and the sediments settled, yet it's covered by many layers of sediments, 39 in all. This was the final piece of evidence that explained the creation of the scablands. The catastrophic outburst flood must have happened time and again. Once each flood had left its mark, the vast glacial dam would advance and the waters of Lake Missoula would start to rise again, continuing the cycle of flood followed by calm. Only when the time of the ice was over did the flood stop. The change from Ice Age to warmer times is governed by how close the Earth is to the Sun. Every 100,000 years, the shape of the Earth's orbit around the Sun changes. This has led some scientists to wonder if the recurring cycle of catastrophe and extinctions on our planet is governed by extraterrestrial forces.
Mass extinctions and the catastrophes that cause them seem to follow a periodicity of about 30 million years. It's that cycle that suggests that the cause of a catastrophe lies outside the Earth. On a clear night here in Africa or in other places where you can see the night sky, we can see astronomical evidence for the cause of these geological catastrophes every 30 million years. Our solar system is on a voyage through the disk-shaped Milky Way galaxy. Every 30 million years, we pass through the densest part of the galactic disk. During that time, the comets of our solar system can become disturbed and fall inward toward the inner planets. During this period, the Earth is more likely to be impacted. This cycle may explain the catastrophic history of the Earth. The last major mass extinction was 35 million years ago. We're in the densest part of the galactic disk now, and the next mass extinction may include us.
Asteroids are a very real threat. They even formed our own moon. Soon after its violent beginning, our planet suffered a ferocious assault. A rogue asteroid bigger than Mars smashed into it with enough power to blast much of the Earth's surface into space. The debris was drawn together by gravitational forces and formed a proto-lunar disk. From that, the new moon grew rapidly, sweeping up the debris in orbit around the Earth. Computer models suggest it only took a year for the fragments in orbit to coalesce and form a single moon.
This is the Clark telescope at the Lowell Observatory in Flagstaff, Arizona. It's a telescope that was used to take pictures of the moon in preparation for the Apollo moon landings. To see the moon tonight, we need the telescope up in this position. And we can make some fine adjustments. The density of the craters on the moon's surface was measured using the photographs taken by the Clark telescope. What's more, the astronauts visited some of these regions in their 6 Apollo missions.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth. I can't believe we came over those mountains.
The largest impact feature on the moon, the Imbrium Basin, is more than 1,000 kilometers across and was produced by the impact of a comet or asteroid more than 100 kilometers across.
Yeah, those are pretty big mountains to fly over, aren't they?
The basin is surrounded by mountains more than 5 miles high. This is where the Apollo 15 astronauts landed and took samples. They show that these mountains are not like the mountains on the Earth, but they're piles of rubble, fragmented rock thrown out by this giant impact.
Look at that. Guess what we just found? I think we found what we came for. Crystal rock, huh? Yes, sir. You better believe it.
The pristine moon rocks that were brought back by the Apollo astronauts have been radiometrically dated and studied. And they show that impact has been an important process in the formation and evolution of the Earth-like planets. What's more, the radiometric dating of the rocks has shown that the moon underwent a hellish bombardment between 4.5 and 4 billion years ago. After that time, the bombardment died down. By that time, most of the asteroids moving around in the inner solar system had collided with the planets, and the process of formation of the planets was over.
200 space rocks, large enough to cause global devastation, are known to be on Earth-crossing orbits, and there may be many more.
Here in Namibia, meteorites have always been considered special objects, worthy of veneration. These meteorites have been put on display as a centerpiece of the city. The impact of small iron meteorites like this would have little effect on the Earth as a whole. But the impact of a much larger object, a 6-mile diameter asteroid or comet, would cause a mass extinction, as we know from the geological record. The impact of a 1/4-mile diameter object, like the one that just missed the Earth in 1996, would cause widespread destruction. A hit in the ocean would cause tsunami that would devastate coastal cities. And a hit on land would produce a dust veil that would produce nuclear winter-like conditions that would threaten civilization as a whole.
The geological record shows impacts brought catastrophe and devastation which wiped out many species. There have been 5 key mass extinctions in Earth's history. Best known are the dinosaurs. Why did they simply disappear from the face of the Earth? India may provide the answer. 65 million years ago, it was still an island drifting towards Asia. This was when the layered landscapes of the Deccan Traps were created. A great volcanic rift spewed out 500,000 square miles of lava. Layer after layer of lava lies on the land in places up to 8,000 feet thick. Some scientists believe that the scale of this volcanic activity was so great it killed off the dinosaurs. Professor Michael Rampino thinks the traps were triggered by an extraterrestrial visitor.
This is the Hoba iron meteorite in Namibia. It's the largest meteorite known on Earth. And like most meteorites, it contains the rare element iridium. And iridium has proven to be the clue, the connection, between the impact event and the extinction of the dinosaurs.
Iridium is found near impact craters, but is extremely rare elsewhere in the Earth's crust. At these craters, the levels of iridium are 10,000 times higher than normal. Such high concentrations have been found in the sedimentary record all over the world at a consistent date of 65 million years ago. Recently, a crater more than 110 miles wide was detected off the coast of Mexico's Yucatan Peninsula. It too was created 65 million years ago. It was formed by a 10-mile-wide cosmic killer which closed on Earth at more than 60,000 miles an hour. It struck with the violence of the world's entire nuclear arsenal exploding 1,000 times over. It sent out a ferocious fireball engulfing the land for thousands of miles around. Enormous fires raged for months, destroying everything in their path.
The impact may have had other catastrophic effects as well. The force was so great that shock waves went out from the point of impact in Mexico around the world and focused and concentrated at the exact opposite point of the Earth, in the Indian Ocean.
The exact opposite point in those days was the island of India, and Rampino believes the violent volcanic eruptions which created the Deccan Traps was triggered by the meteorite. The effects of the impact explosion and the volcanic flood poured millions of tons of dust and ash into the air, plunging the world into darkness. Nitrogen, sulfur, and oxygen in the atmosphere combined to form acid rain as the Earth cooled. In this cosmic winter, 75% of all living things perished. When the skies cleared, the dinosaurs had gone. Human time span is so short, it's hard to understand that we will be undone by forces that play out over millions of years. In Utah, the shells of countless millions of marine creatures which lived and died here have been exposed where the San Juan River creates a great tear in the Earth's crust. The river has revealed a lost world. 200 million years ago, the shallow seas once lapped the shores of the giant supercontinent Pangaea, which stretched unbroken from pole to pole. 50 million years ago, this entire region underwent a cataclysmic change. Erosion began relentlessly stripping away layer upon layer of rock. The tectonic forces which squeezed, compressed, and lifted the land were locked in an endless battle with erosional forces, carving fantastic landscapes. Water is the strongest force of all. It cuts through solid rock to create deep canyons. With terrible patience, it will scour away the stone and shape the rocks. One day, In an unimaginably distant future, Antelope Slot Canyon will be as wide and as deep as the Grand Canyon itself. The 1,000-foot-high sandstone pillars, buttes and mesas that rise above the plains are the memorials to millions of years of the geological battle. But they too will disappear. Nothing can withstand erosion. Sculpting the surface, gouging out the deepest ravines, cutting down the tallest mountains, nature finds its own equilibrium.
The small mining town of Colemanskop, abandoned just a few decades ago, is already being invaded by the sand dunes. Eventually, it'll be entirely covered. If we turn our back for one moment, the geological cycle of erosion and deposition will take over.
Professor Rampino knows from his work in the Namibian desert how the tectonic dance will end. Scientists may argue about the short and medium term, but the further ahead they look, the clearer the vision becomes.
The sand in this dry riverbed in Namibia is part of an endless cycle of erosion and deposition. The sand is formed by erosion of granite outcroppings and carried downstream by rivers to the coast and picked up by ocean currents, moved along the Namibian shore to form the long beaches of Namibia. Some of the sand is blown inland to form dunes. The sands can be consolidated into sandstone and then be eroded again to form new sands, part of a cycle from granite to sands to sandstone and back to sand again. On a human timescale, not much happens, but on a geological timescale, all that we have done and all that we have made will be destroyed.
So, at the end, Earth has no future. Through millennia to come, the unfamiliar continents will form and move on as the plates continue their wanderings. Rivers will change their courses, oceans will empty and fill, and mountains erode and rise again. But our sun is aging. In 5 billion years, it will run out of energy. As gravity tightens its grip, it will collapse on itself, the temperature rising to 100 million degrees. It will expand uncontrollably, engulfing Mars, Venus, and the Earth. The seas will boil away, the atmosphere evaporate as Earth becomes a charred ember. Then the sun will cease all nuclear fusion and die. It will be the end of our amazing Earth.